Good morning, class. This is Mr. Berg. We're going to go through Intro to Network Fundamentals, Part 2 on this recording. This is for anyone who might have missed the class that wants to catch up on the material. Let me put it in SlideShare and we will get started. All right, so we'll do Part 2 in this video, then I'll do a separate video for Part 3. Part 2, as you can see, Part 1's already been covered. The video for that has been uploaded into Canvas, and you can see the topics in Part 1. Part 2, we're going to get into the protocols today, and especially into the Internet protocols. That's the focus of this class. IPv4 and IPv6 addresses, we covered that in a separate module. So I'm going to touch it quickly, but primarily most of that material was covered in module 1 already in the network addressing module. And then part 3, you'll see the materials coming up for the next video. Let's get started. Before we get into protocols, and again, protocols are an agreed standard for how devices communicate. Let's talk about the layers of defense. And we're going to get into security zones. But if you look at this picture, simply put, data is at the center core. That's what we're really trying to protect. Your data is wrapped in application security. Your applications are wrapped in the host or the server's security. And then all of the above is wrapped in the network. The network is the outer perimeter. So essentially an attacker or an external body has to come through the network and the security there, be it passwords or checking for IP addresses and firewalls, get to the host. They then have to have the appropriate credentials and information to log into a host environment. Then they get to the application. They then have to have the credentials and the passwords and approvals and authorizations to get into the applications. And then finally, they get to the data. So all said is your first line of defense at the perimeter is the network. And then the final line of defense is the data. Now, the data itself can also have defense techniques employed like encryption and backups and things like that that help, if not secure the data, will prevent, if you lose the data, a way to recover. All right, so the data is at the core, the network's at the outer perimeter. Each layer adds additional defense to protect your data. We're going to get into today, we did a classroom exercise, but look at this picture. You're going to see a topology where you have the internet, the public network way over to the right, coming in through a firewall. Now that firewall prevents internet access directly into your internal zone over on the left, your workstations, your servers, and it prevents you from going down to your application servers and databases below. And we're just going to go through a couple of terms that you have here. First of all, remote internet access. Oftentimes, that is, you add security by forcing, if they are trusted individuals, to come in from a VPN, a private network, a virtual private network. We're going to talk about that in a later section. Number 2, you have the firewall. Simply put, that is a server. It's hardware and software that is on the network path, that is reading every network packet coming in and making a decision. Do I allow this packet to go through? And if so, where is it allowed to go? Or do I block it and report back? So firewall basically employs security rules on every network packet. Now, if we go north and we look at a couple of servers, they're sitting in something called a DMZ, which I'll talk about in let's do the DMZ and then I'll do the servers. A DMZ is a demilitarized zone. It's a term that came from the Korean War, where you had a zone between two enemies. The U.S. and South Koreans are on the south, and the North Koreans were on the north. They had this space of land, I think it's about a mile wide, where both parties agreed, I am not putting any of my forces. It's a safe zone, and it's a buffer. It's a buffer. So a DMZ, from a technical standpoint, is a buffer zone or a safe zone where we will put resources that are accessible from the internet, and they are accessible from our internal zone. but the internet can't get to the internal zone, nor can the internal zone get directly to the internet. Everything has to pass through this buffer zone. And in the buffer zone, you put certain servers or controls that protect, defend, detect, minimize risk. So, for example, a proxy server. Simply put, a proxy is a broker. So you have a server that acts as an intermediary between your internal and the internet. So if somebody in the internal zone wants to send something to somebody in the internet, it'll go to the proxy, or wants to connect with something in the internet, they go to the proxy. The proxy will then, using its IP address, not the internal user's IP address, it'll use its IP address to communicate out to the internet. So the internet thinks it's talking to the proxy and the proxy only. That's the only credentials or address information exposed. The internet body, servers, resources will never see the internal users or workstation or server address information. Email, essentially the same thing. Email comes in from the internet to an email server. Then the internal users go to the email server to get their email. Now, a lot's going on at that email server. You can, because oftentimes that's probably the top way you're going to be attacked, is some malicious, mysterious email coming in, trying to trick individuals into clicking on something, downloading something, or doing something. So on the email server, you have things like spam filters, filtering out the junk. You have banners and other junk, looking for malicious file types, addresses, and things of that sort. So you put a lot of controls in on your email servers. If not as simply as put warnings up. So when the internal user goes to the email and looks at an email, they may see a big banner say, hey, we don't know where this is coming from. We don't know if this is a trusted source. It looks malicious. You broadcast, or you put banner information on the actual email, so the user, when they do look at it, can look at it with some discretion. All right. And then a web server. This is your enterprise organization's actual web server. This is howard.edu. This is yahoo.com. This is amazon.com. This is the, if you will, external facing, public facing web server. And you want the external users from the internet to be able to get to that, but not get to your data that is residing on your application servers or your user workstations and internal servers. Okay. So those are three examples of external servers that you want to at least expose to the internet: proxy, email, and web. And they sit in a buffer zone called a DMZ. There are a bunch of things you can do in that DMZ. For example, the DMZ may be in a physically segregated space or area. It may have additional logging and tracking and monitoring, because your operations center says, instead of monitoring our internal servers, let's really keep an eye, hour by hour, day by day, what's going on the proxy, email, and web server. That's where something malicious could happen. That's where an attack may target, or the server resource that they may target. Okay. Now, I'm not going to talk about the application servers and the database servers, other than to say they're in their own buffer zone, because that's where your data is. And even internal users, you have very limited or selective access to the applications and the databases. Not all internal users can get to all data, can get to all applications. Okay. All right, now we go into part 2. We're into the protocols. We're going to talk about some frameworks in just a minute, but simply put, I'm going to focus in on 4 layers. At the top layer are some protocols. Again, these are agreed upon standards for communication. And then I'll take you down through each layer, but the concepts we're going to talk about today are protocols. We're going to talk about frameworks, OSI and TCP. And we'll see in a minute, OSI has 7 layers, TCP has 4, and the 4 are pretty much represented over on the right. And datagrams are simply units of data. We call them segments, packets, and frames. We'll talk about that quickly. Data encapsulation, and of course, network packets. That's again, the unit of data passing through the network from source to destination. All right, so first let's do our frameworks. The Open System Interconnection Model, OSI, very popular, has 7 layers. I don't need you to memorize all 7. Just kind of see and know that there are 7 layers. I'm going to focus this in on 4 of those layers, the 4 most important. But the point of the framework is to organize protocols by kind of what they do. There are some protocols that are up in the application area which interact with the user. It's about the user experience, what they see, what they do. That's way up top at the application. That data then is passed down layer by layer as it's on its way to its destination. And it goes through a presentation, a session, a transport, a network, a data link, and then finally it gets physically to wherever it's supposed to go. And let's say it's to get to the printer. It finally gets to the printer. Hold on, I'm going to show you a simplified version of the model that I think we're going to use in the class. So the OSI model has 7. The TCP, and again, TCP is a protocol. It uses 4 layers. They do map, but we focus on the TCP side on the application. That's the user experience. We then drop down to the transport layer. That's where TCP actually establishes, puts its connection information. How are we going to connect with our endpoint? The internet layer is where, otherwise called the network layer, network or internet layer, that's where they actually put the IP address on the data, the IP address, and start routing it to its destination. Once it gets to its destination, it goes down into, they call it host to network or data link and physical. The physical layer where it gets to its destination. Now it's got to get to the printer at that destination. It got to the building based on an IP address. Now, what physical device does this IP address, is its IP address linked to? All right. So using those 4 conceptual layers, we have an application layer way up top where the user interacts, and the user is interacting. I'm going to point out a couple popular, and these are kind of the ones that I would call out. HTTP, that's what you see in your browser. That is when you go to your browser, you type something in HTTP. And when we use HTTP, we really mean HTTP S, which is the secure version. We'll talk about that at length in this presentation. TLS, that is a protocol that is encryption that is used in the browser. So when you use HTTPS, you're using TLS encryption. We'll talk about that at length. That's transport layer encryption security. And then the DNS, that's the domain name service. That's where you go get information. Yahoo.com is actually IP address 192.144.1.6. That's where you go to translate the textual domain name into a numeric IP address. All right, so those are just a few examples. Transport layer gets your TCP and your UDP. Again, the key takeaway here is TCP is connection oriented. It establishes a connection. It dials the phone, and it will make sure when that connection occurs that all the data gets to its destination and gets acknowledged. If it doesn't get to its destination, it will reset and resend, but the transmission is not complete until everything gets there. So it is connection oriented. Okay. UDP, on the other hand, is connectionless oriented. We'll talk about that for a minute. That's applications that just want speed. you're broadcasting, you're streaming, you're doing music, audio, phone. We don't want to slow down to make sure every little bit and byte got to its destination in order. We need speed and volume. All right. We primarily use TCP. That is the primary protocol that we use. It's used to transport data. Okay. The network layer is where we put an IP address on the data packet and send it to its destination through the internet. So you're using IP4 or IP6. And then finally, you get down to the link layer, and that's the physical layer. Once it gets to its destination, how do we get it to the actual device? Are we talking to the device over some wireless connection, over Ethernet, which is a hard wire connection? Okay. All right. The chart on the right might be a little busy, but we want you to see how data is packaged, and this is called a datagram. Data up at the higher levels is just called data. Once you get to layer 4, which is the transport layer, it's called a segment, and the segment includes the port information. At layer 3, which is the network layer, that's where you put the IP address on it. The IP address is included on a packet. Then it becomes a frame, and you add the MAC address. And finally, it has bits and bytes. That's the physical layer. That's the actual binary data that is going to the printer. Right. So I'm going to show you a picture again and show you how all this data is packaged together. So all this data essentially gets encapsulated within each successive record. And we'll show you that in a second. Here we go, encapsulation. So as we saw in the prior chart, we might have a segment and it has port information. Well, that segment becomes part of a packet. So it's data in a packet record, and the record they append to that, the IP, the source and destination IP information, and some protocol information. That packet gets encapsulated in a frame, and that frame has the source and destination MAC address, the MAC address. So you can see the data just gets encapsulated. A small envelope gets put in a bigger envelope with a new address on it. The bigger envelope gets put in an even bigger envelope or box with a new address on it. And each layer has some addressing information that layer of network activity needs. Okay. And you can look at this. This is a backup. And if it's a backup, I'm not going to spend time on it. All right, so routing, and I keep going back to layer 3. Layer 3 is critical because that's where the data is transmitted over the internet, and that's where we put the IP address on it, and that's where we use something called routing. Routing connects different networks together. And IP addresses, you can use it different ways, but typically it's going to get you to something that has an IP address. So for example, in your house, you have your wireless router. So in the house, you have your wireless device. It connects to your Wi-Fi router that's in one of the rooms of your house or apartment. And on the back end of that, it connects into your internet service, into your Xfinity, your Comcast, or whatever service you connect to for internet service. Okay. So it takes Wi-Fi network and connects it to an internet service in that router. It's connecting your Wi-Fi to your IP address. Okay. But routing essentially is transferring data between different networks. And typically an IP address is going to be involved. Okay. A packet is a unit of data for the network, especially at the network level. It is actually called a packet, and it has an IP address. You can look at the chart here, but a packet is where they take large chunks of data and break it down into smaller chunks of data. Each chunk has its own sequence number, so it can be reassembled on the receiving end. And the network can be real smart. Hey, I got to get all this data from point A to point B. I may send different packets on different routes as long as it gets to its end destination. Now remember, with TCP, the mission's not done until the receiver gets all the data and can acknowledge I got all the data, all the sequences, and I can reassemble it. If it does not receive the data, it does not acknowledge, and a resend or reset has to occur, and the data has to be retransmitted. So here's a summary of this section. I'll let you look through, but we talked about protocols and the different, then we talked about the OSI and the TCP protocols, protocol frameworks, the layers. Datagrams are units of data. That's where we talked about segments, packets, frames, bits. Encapsulation is how data, those different segment is encapsulated into a packet, packets encapsulated into a frame, frames encapsulated, and so on. So that's, and then network packets is just simply, generically, it's how you break data up, but more specifically, it is what we do in the network layer where we put the IP address on it and get it to its end destination through a public network. Okay. All right, I'm gonna go through the internet protocol because this is really where we're going in this class. Again, I'm calling out four layers. These map to the TCP. The application layer is where you have user services and protocols that are used for user services. And you can see examples over on the right. Through repetition, you're going to become familiar with what these are. The transport layer is where we have establishes kind of the connection. What kind of connection are we going to do? TCP, which is connection oriented, UDP, which is non-connection oriented or not connection oriented. Over on the right, you'll see on the transport layer, you see TCP and UDP. You also see SLS and TLS. That's encryption. We're going to talk about that very specifically. That's a form of encryption that's used when you're doing internet protocols, especially from the browser. The network layer is where you put the IP address on it. And we show a protocol way over here on the right, ARP. That's Address Resolution Protocol. That essentially bridges your network connection, the IP address, to the physical connection, the MAC address. So ARP will then take data that comes in under an IP address and map it to a MAC address at the physical layer. You'll see that in a minute. Okay. All right. Again, another picture of encapsulation, because it may sound all a little confusing, but say over on the right is where we have a segment of data. That's at the transport layer, a TCP segment, and it has port information. You can see on the top row, source and destination port. It has been encapsulated in the IP packet, and the IP packet in its header will have the IP address. So simply put, we want to show you, although we talk about these different layers and these different units of data, they all are encapsulated in each other. So once we look at Wireshark, we'll see a record come across, and we can see data for each layer in that same record. So all the data that you may see, the MAC address is in there, and the IP address is in there, and the port information is in there, because all the data is packed in or encapsulated in that record, in that data pack, in that datagram. Yeah. All right. Okay. I'm gonna keep going here. I think we'll hit this a little. The IP protocol, IP packets. And IP packets have, yeah, let's keep it going here. I'm gonna, application layer, you see the chart, we're up at the top. These are different services, and here you'll see the different protocols, excuse me. Couple of things. Each of these protocols, as we go through the network from a source to a destination, be aware that each protocol will have a corresponding port on the destination. If we're talking HTTP from a device to a web server, we're coming in on port 80. So there are ports reserved. Certain port numbers are reserved. for each of these protocols, right? You can read these on the right. You can see telnet is where you emulate a terminal. SMTP is mail. POP is also mail from any device. HTTP, and I'm going to give you the other side of that, HTTPS. That's where you are in your browser. You're talking to a web page. FTP is file transfer, and domain DNS or domain name system is where you are looking up the domain name and mapping it to an IP address. Amazon.com is 9. Whatever. Okay, and here's that picture. So for each of those protocols, we have a port number reserved. So when we communicate, we're doing an FTP. We know the control data goes to port 21 and the actual FTP data goes to port 20. So it's a way to address. And the receiving end says, hey, look, I don't handle FTP data on any other port but port 20. So again, that's the endpoint on the device for each service, and a service is a protocol. Okay, and you can see some popular port numbers here on the right. All right, it's TCP and UDP. We hit these before. The key takeaway is TCP guarantees the reliability and delivery of the data, and it does that using a three-way handshake. We're going to do an example of that in just a minute. Three-way handshake is simply put that TCP will make sure that the receiver is ready for the connection. The receiver will acknowledge back that I'm ready for the connection, and then they acknowledge back to each other. And when they make that acknowledgement, they're basically saying, providing some information. I'm going to send you something. Here's the sequence number and some information about it. The receiver says, "Yep, I'm ready to receive it. I acknowledge your sequence number." Then the sender says, "Okay, let's do it," and they have a handshake. They are ready. They are connected. They're ready to transmit. UDP, on the other hand, is connectionless. It's just high speed, and it's used for certain applications like streaming and broadcasting and things of that sort, where speed is more important than quality. Okay, and here's the three-way handshake. TCP knows these terms send, SYN-ACK, and ACK in the order in which they occur. Send means synchronize. So the sender says to the receiver, I'm ready to send you something, let's synchronize. And I'm going to send you some information like sequence number and things like that. Let's get in sync. And then the receiver, in this case, a server, says, I'm going to do a synchronized acknowledgement. I got your data. I'm acknowledging back how I'm going to use those sequence numbers and information. Then the sender says, I'm acknowledging your information you sent back to me. So three-way handshake, send, ACK. Okay. If something were to fail, an RST would be sent instead, which is a reset. Let's terminate, try it again. So on the back end of the TCP, now we've had the handshake up front. Now we send the data. So the data is transmitting. On the back end, we do a receipt confirmation, and that's a finished FIN. The receiver acknowledges, okay, I acknowledge we're finished, and I'm going to send a finish to you. I'm done. And then the sender sends the final acknowledgement. We're good. And we close the connection. So we have finish, acknowledge, finish, and acknowledge. Right? And behind the scenes and under the covers, they're checking to make sure I got all the receiver checks. Did I get all the sequence numbers? I'm checking the checksums to make sure all the data is the integrity of the data. Nothing's been compromised. And then I'm acknowledging back to you the acknowledgement that I got it. We're good. We can close. Okay. And this is backup, but this is, if you looked in Wireshark, you would see those actual records going back and forth. Okay. All right. Now we're down, let's drop down to the network layer, which is where the IP address is added, IPv4, IPv6. There's some other things that go on there. There's another protocol called ICMP where that's where a system sends a broadcast message, and it's using the internet to broadcast. Okay, we focus mostly on the IP addressing, and then we can also put some security IPsec. We'll talk about that later, but IPv6 has security integrated in it, but there's a way when we do IP addressing and routing, we can add additional security for data authentication, integrity, and confidentiality. Okay. And then once it gets to its destination, the ARP takes over. It's layer 2, but it takes over and it says, okay, you came in with an IP address. I have to map that to the physical device or to the MAC address, the physical device's MAC address. There we go. So here are the layers we just went through. The application layer, these are the user services. The transport layer, that's where we put our TCP or UDP on it. That's where we do our three-way handshake. The IP address is the put the IP information on it and physically route the packet to its destination. And then the data link layer is where the ARP comes in and says, okay, I got a packet. It has an IP address. I now need to map that to a MAC address. What physical device do I have to send this to on my end? Okay. And that's where we're going to end part 2. Thank you. If you have any questions, please contact me. The next video will be part 3. I'll see you then. Bye-bye.